In today's lesson, we will be talking more about slope, and we're finding the slope between 2 points. And we've already kind of done this by graphing the points and then using rise over run. But in today's lesson, we're actually going to find the slope without graphing. But you can always go back and check your answer, because any 2 points, just picking any random points, you can connect them to make a line and then use rise over run to find the slope. But we're going to find that slope without having to even graph our points. So here is the formula that we're going to use to find the slope between 2 points, and it actually looks a lot more complicated than it actually is. At the top, this right here, this x1, y1, x2, y2, is just our way of showing that every coordinate point has an x and a y, and then the 1s and the 2s are just saying that this is the first point and this is the second point. So our formula, m, remember, is slope, y2 minus y1, and I like to draw arrows. You start with y2, you subtract y1. So we're just finding the change in your y values, and then the change in our x values, we're going to do x2 minus x1. So, simple as that. And now technically, you can also have this formula will work the same as if you do y1 minus y2 divided by x1 minus x2. As long as you are consistent with your arrows, you'll get the same slope. So notice on the first example, I'm going from right to left. On both arrows, they're going the same way. And then on this right example, I'm going from left to right. And now I'm going to show you the common mistake that students might do when they mess up this formula. So the common mistake is when students aren't consistent. When they go from their second point to their first point for their y values, and then opposite for their x values. So when your arrows are going in opposite directions, now the formula doesn't work anymore. So we don't want to do that. And then just for consistency, I will always do this one, from the right point to the left point. Alright, so now let's actually find the slope between these 2 points. So my y values, if it helps for the first few, you can rewrite x and y, x and y. So I need to find the change in my y values, 6 minus 4, and then I'm dividing by the change in my x values, 4 minus 3, my arrows are going the same way, and 6 minus 4 is 2, 4 minus 3 is 1, and 2 divided by 1 is 2. So my slope, m, equals 2. So here we have another example, and anytime there's a negative number, it does make things a little trickier because we're subtracting negatives, and you just have to remember the rules of when you subtract negative numbers. But we've got our y values, 1 and 2, so 1 minus 2, and then my x values, 1 minus negative 1, so 1 minus negative 1. 1 minus 2 is negative 1, and then when you are subtracting a negative, remember, add the opposite, so it's one big addition. So 1 plus 1 is 2. Negative 1/2 is a simplified fraction, so I'm going to keep it as that. My slope is negative 1/2. So once again, same thing, but lots of negative numbers makes it a little trickier. So I've got the point negative 3, negative 4, my x and y, and then 0, negative 3. My y values, negative 3 and negative 4, so negative 3 minus negative 4, negative 3 minus negative 4. divided by my x values, the change in my x values, 0 minus negative 3, 0 minus negative 3. So then if you add the opposite, it really ends up being negative 3 plus 4 over 0 plus 3, which equals a positive 1 over 3. And that is a simplified fraction, so my slope is 1/3. Alright, in this example, it is a special case, and you will find out why after we use our formula to find the slope. So xy, xy. My y values, negative 2 minus negative 2. And then dividing by negative 3 minus 5. So negative 2 minus negative 2. Add the opposite. It's negative 2 plus 2, which is 0. And negative 3 minus 5 is negative 8. 0 divided by anything is 0. So now I just want to refer to a graph, and let's think about why the slope is 0. If I graph those 2 points, 5, negative 2, and negative 3, negative 2, when the y value is the same, it creates a horizontal line which has slope 0. So that is, anytime the y value is the same, it will create a horizontal slope, which means your slope is 0. Alright, in this one, it's another special case, but let's just go ahead and solve using the formula. 3 minus 7, those are my y values, and then divided by my x values, which is 1 minus 1, negative 4 divided by 0, and red flag, you can never divide by 0, so what do you think the slope is in this case? It is undefined. And I also want to quickly plot these points on a graph so you can see what it looks like. So if you plot the point 1, 7, and then plot the point 1, 3, it creates a vertical line. So when a vertical line has the slope undefined, so anytime you have the x value repeat, that means it's going to have a vertical line and the slope will be undefined. Alright, so here's the last example. We're going to do it together, and then you can try 3 on your own quickly. And we have all negatives. Negative 3 minus negative 1. And whenever I'm subtracting a negative, I sometimes will even skip and just say it's going to be plus 1. Because that double negative makes plus. And then negative 2 minus negative 8. Negative 2, instead of thinking minus negative, I just make it plus 8. And negative 3 plus 1 is negative 2. And then negative 2 plus 8 is 6. But your slope always has to be simplified, and that simplifies to negative 1/3. Alright, so here are 3 examples. I want you to pause the video and write them down, and then quickly try them all on your own, and then come back and check your answer. The first one is negative 8/5, which is a simplified improper fraction, and we will keep it as an improper fraction. The second one is undefined, and that's because the x value repeats, and it will create a vertical line. And then the last one, you should get 3/4. So there's your full lesson on finding the slope between 2 points without having to graph the lines. But if you're ever stuck, you could always check your answer by graphing them and using rise over run. Good luck with the lesson.